Hey there, math enthusiasts! Today we're diving into the world of trigonometry, and trust me, it's not as scary as it sounds. We're going to break down the basics of sin, cos and tan, the holy trinity of trig functions. By the end of this video, you'll be seeing triangles in a whole new light. So, what's the big deal about trigonometry anyway? Well, it's the secret sauce behind everything from building skyscrapers to navigating ships at sea. It's all about understanding the relationships between angles and sides in triangles. And let's face it, triangles are everywhere in our world. Let's start with the foundation, the right triangle. Picture a slice of pizza. That's your right triangle right there. You've got three sides. The opposite, the side across from the angle we're looking at. The adjacent, the side next to our angle. And the hypotenuse, the longest side, always opposite the right angle. Remember these, because they're the key players in our trig functions. Now let's meet the stars of the show, sine, cosine and tangent. First up is sine, or sin for short. It's the ratio of the opposite side to the hypotenuse. Think of it as measuring how tall something is compared to its total length. Cosine, or cos, is the adjacent side divided by the hypotenuse. It's like measuring how far something stretches horizontally. Last but not least, tangent, or tan, is the opposite over the adjacent. It's great for finding slopes and angles. Struggling to keep all this straight? Don't worry, I've got a memory trick for you. So-ka-to. It sounds like a magical incantation, but it's actually a handy way to remember these ratios. Sin bakt opposite at hypotenuse, cos at adjacent, hypotenuse, tan, opposite or adjacent. Say it with me, so-ka-to. Now let's see how these functions play out in the real world. Architects use trig to calculate the height of buildings and the angles of roofs. Engineers rely on it to design bridges that can withstand massive loads. GPS systems use trig to pinpoint your location on Earth. Even your smartphone camera uses these principles to focus and capture images. Pretty cool, right? Let's put our knowledge to the test with some practice problems. We'll start with a right triangle where one angle is 30 degrees. The hypotenuse is 10 units long. Can you find the length of the opposite side? Remember, we're looking for sin 30 degree multiplied by the hypotenuse. Sin 30 dig is 0.5, so 0.5, 10 or 5 units. See, not so tough after all. How about a 45, 45, 90 triangle? These are special because the two legs are always equal. If the hypotenuse is 10 units, what's the length of one leg? We'll use cosine this time. Cos 45 degrees is about 0.707, so 0.707, 10707 units, math magic. Last one, a 60-degree angle with an adjacent side of 8 units. What's the tangent? Tan 60 degrees is about 1.732. So if we multiply 8 by 1.732, we get approximately 13.86 units for the opposite side. You're getting the hang of this. As we wrap up, remember that these basics are just the tip of the iceberg. Trigonometry gets way more complex and fascinating as you dive deeper. You can explore concepts like the unit circle, inverse functions, and even trigonometric identities. But for now, pat yourself on the back. You've conquered the fundamentals of sin, cos and tan. So next time you see a triangle, whether it's in a textbook or out in the world, you'll have a new appreciation for the mathematical relationships hidden within its angles and sides. Trigonometry isn't just about memorizing formulas, it's about understanding the beautiful patterns that shape our world. Keep practicing, stay curious, and remember, every problem is just another opportunity to flex those trig muscles. Who knows, you might find yourself looking at the world through triangle-tinted glasses. Until next time, keep calm and trig on.